Alright, you guys, so as promised, I'm making a video on more review problems. So what I did was I went back to, we did the review problems on page 392 today. I selected certain problems which you should all have in your notebook. And all I did was go back into those sections and find similar problems to do more of a review for extra practice. Alright, so the first one I'm doing here is number 9 from that section. And what you're asked to do is simplify the tangent squared times the cosecant squared minus 1. So in other words, you want to use some kind of identity to replace something, so that way you can simplify this whole thing. Well, what we know from identities is that the cosecant squared minus 1 gives us the cotangent squared. So we have the tangent squared times the cotangent squared. So I'm replacing this with this. And the other thing we know is that the cotangent has a reciprocal identity of 1 over tangent squared. So what happens is that I can cancel this and this, right, because it's multiplied. And so what I'm left with is 1. Done. A number 20, we have to simplify again. So we have secant squared cotangent x minus cotangent x is equal to the tangent of x. So this is more of a verify. In other words, I need to take the one side of the equation and make it, or work it out so that way it equals the other side. So this is the more complicated side, so this is the side I'm going to start with. It's going to be really hard for me to take this and make this, right? So anyway, what I did was I factored out, I noticed in each term here I have a cotangent of x, so I factored it out, and I rewrote what's left. Don't forget that factoring is division. So I hate to do this. Let's see if pink will work. I hate to do this, but you know, if you're, whatever you're pulling out is what you're dividing each one of these terms by. So we're pulling out a cotangent of x. That means I'm really dividing each one of these by a cotangent. And over here the cotangents cancel, so I'm left with a secant squared, a minus, and then this divided by that gives me a 1. Okay? So what I'm left with is the cotangent times the secant squared minus 1, and if you remember, the secant squared minus 1 is equal to the tangent squared. So I'm replacing this with this identity. Again, the cotangent, it has a reciprocal identity of 1 over the tangent of x, and at this point here, because they're being multiplied, I can say that tangent of x goes into tangent of x once, and tangent of x goes into tangent of squared x, tangent of x. So one of these cancels. So I'm left with the tangent of x. Okay, number 28, we start back into equation solving, which I said to you in class is going to be the brunt of your test. Okay, so they're asking you to solve 4 cosecant of theta equals 1 plus 2 cosine of theta. So remember, I don't want to be dividing back and forth. I want to be adding or subtracting to move terms over or to collect like terms. So I subtracted 2 cosine x from both sides. When I subtract it here, I get a 0, so I get 1 plus 0, so I get a 1. And over here, I've got 4 cosine x minus 2 cosine x. Well, these are the same thing. So all I have to do is subtract the coefficients, and I get 2 cos x equals to 1. Now I can divide both sides by 2, so the cosine of theta is 1/2. And now I have to remember from my unit circle, when is the cosine equal to 1/2? Now in number 28, let me just double check, an interval was not given. Okay, so what that means is, because I'm dealing with a cosine, I know the period is 2 pi, right? So there's going to be infinitely many coterminal angles that are solutions to this thing. And so if I look back at my unit circle, so I just printed a copy online, from online rather, and this thing's pretty busy, but anyway, you know, I want to know when the cosine is 1/2. Well, the cosine is positive in quadrant 1 and quadrant 4, right? Those are the two quadrants the cosine is positive in. And in quadrant 1, the cosine, which is the x value, is 1/2 at pi over 3, right? So, you know, if this is my angle pi over 3, if I go 2 pi, if I add, you know, if n is 1 and I go 2 pi, then I end up here again. If I go 2 more pi, I end up here again, right? So that's your 2n pi. The other one down here, if you look, is 5 pi over 3. So you notice that the denominators are going to be the same, right? and there's your cosine of positive 1/2. So the answer is just pi over 3 plus 2n pi and 5 pi over 3 plus 2n pi. Not too much to do there. It's a pretty simple equation to solve. All right, in number 34, now we have an interval that's given, right? So I don't have to add n pi or 2n pi to this. And so we have 2 cos squared x plus 3 cos x equals to 0. And what I notice is that each term contains a cosine of x, so I factored out a cosine of x. If I factor a cosine x here, I'm left with 2 cosine x. Bring down the plus. If I divide by a cosine x here, I'm left with a 3. So what I have are these two factors. The cosine of x times 2 cosine of x plus 3 equals 0. And so I can take each one of these factors and set them equal to 0. So remember, I must see this in your work. Well, I know that the cosine of x from 0 to 2 pi equals 0 at pi over 2 and 3 pi over 2, right? And this one I get a little bit more work because I got to get this cosine by itself. So I subtracted 3 from both sides and then divided by 2. So the cosine of x is equal to negative 3/2. And 3/2 is bigger than 1, whether it's positive or negative. So remember, the cosine fluctuates between positive 1 and negative 1 on the graph. So we would just say there's no solution for that. So the solutions here would be pi over 2 and 3 pi over 2. In number 45, we have another problem to solve, and this is factoring. And again, if this is bothering you, over to the side, just, call it x, call it u, whatever you want. Say let u equal the tangent of x. So if I replace tangent squared x with u, I get u squared plus u minus 6 equals 0. And if that's easier for you to factor, do that, and at the end back substitute your tangent of x back in, right? So I'm going to work over here for a second. This is u times u, right? I'm going to have a product of binomials here. So this is a perfect square, so I'm going to put a u here and a u here. And now I have to find the factors of 6 such that when I add or subtract them, I get a 1, right? Coefficient of 1 in the middle. Well, I know that 3 minus 2, right? 2 times 3 is 6, and 3 minus 2 is 1. But if I want my sign to be positive, I need to put my positive in my binomial by the bigger number. So if you FOIL this back, you're going to have u squared plus 3u minus 2u gives me 1u, and negative 2 times positive 3 gives me a negative 6. Alright, so what I can do at this point now is I can solve. I can say, u equals 2 and u equals negative 3. And I can replace my u's now with my tangent. I let it equal to, well, actually, this should have been a theta. Tangent of x, tangent of theta, whatever you're working in. So I can say tangent of theta equals 2 and tangent of theta equals negative 3. So I get exactly what I ended up with here. Okay? So if that's easier, replace it with a u or an x or something. Now, here's the thing. I don't know what angle the tangent equals 2 at. Okay? If this were a 1, I would say, well, theta equals pi over 4, right? If this were a 0, I would say, well, this happens at 0 or pi or something like that. But it's not. This is a number that's not in my unit circle. So all I do is take the arctangent of both sides, which, like I said in class, you do anyway, technically. So you just leave it like that. Theta is equal to the arctangent of 2 plus n pi, because the tangent period is from 0 to pi. So a tangent, it's n pi that you're adding. No interval was given up here, so you're going to add that n pi. Over here, I don't know what angle the tangent equals to 3 at. If I look on my unit circle, there's nothing where the tangent equals negative 3. So again, I just say theta equals arctangent of negative 3 plus n pi. Done. Number 48. Okay, so we did number, I think, 47. No, 40. What did we do in class? We did number 47 in class, so I'm doing 48 on this one. Right, you have to find the sine, the cosine, and the tangent of 375 degrees. And again, they split it up for you. Alright, so again, you've been working mostly in radians, right? So you have to know, that's why it's so important to know all of the angles, both in degrees and radians on the unit circle. If you're not sure, you can convert those to radians and then can convert back to degrees. So if they start you in degrees, you should end in degrees. You should work in degrees, alright? But anyway, you know, this is the sine of 375, or the sine of 135 plus 240. Well, that's the sum formula, right? It's sine cosine plus cosine sine. Sine of u, cosine of v, plus cosine of u times sine of v. So again, you'll have a formula sheet for that. Well, you know, I might say, well, I know where my angle 1s are. I know my quadrant 1 angles. I know where they are. And I know them in radians. Because some of y'all today in class didn't even know 45 degrees, 60 degrees, or 30 degrees. So you need to know that. You need to get back on that unit circle. All right? And so once again, we have what? 135 and 240. Well, 135 degrees is right here, which is the same as 3 pi over 4. And 200, what did I say? 240 degrees down here is 4 pi over 3, right? So what do I know? Well, at 3 pi over 4, that's easy. The cosine is negative in quadrant 2, and the sine is positive, and they're both the same. So that's a good one, right? Down here, though, this is 4 pi over 3. They're both negative. That's nice. But the cosine's 1/2, and the sine is root 3 over 2. So what you're going to have to do is take those values and plug them in. The sine of 135 is root 2 over 2, and it's positive. This is quadrant 2, and the sine is positive in quadrant 2. The cosine of 240, which is a quadrant 3 angle, is negative and 1/2, plus, now the cosine of 135, that's a quadrant 2 angle, so the cosine is negative, and it's root 2 over 2. Times the sine of 240, well that again is quadrant 3, and the sine of a quadrant 3 angle is negative, and it's root 3 over 2. So if I multiply these together, okay, sorry, I had a phone call. If I multiply these together, I'm going to have, so you know, if you multiply the denominators, you're going to have 2 times 2 is 4. In the numerator, you're going to have root 2 times negative 1 is negative root 2. Bring down the plus. Negative root 2 times negative root 3 gives you a positive root 6 over 4. And you can leave it as, you know, negative root 2 plus root 6 over 4. Or you can write it as root 6 minus root 2 over 4, which has math etiquette, but I would give you the points either way. If you can get either one correct, you're good. Okay, here's another one. The cosine, right? So now I have to do the cosine of 135 plus 240. Well, that's cosine, cosine, sine, sine. And if this is plus in here, then we have a minus here. And again, you will have a formula sheet for that. So the cosine of 135, again, if I look at my unit circle, I mean, you don't need, oops, that's the wrong one. That's the first print I did. If you look at the cosine of 135, you know, it's negative root 2 over 2, right? So the cosine, and you can just take those numbers from the problem above, but this is negative root 2 over 2. The cosine of 240, that's quadrant 3. It's also negative, so it's negative 1/2. Minus the sine of 135, quadrant 2, the sine is positive, root 2 over 2. And in quadrant 3, the sine is negative, root 3 over 2. And again, if I multiply these together, a negative times a negative is going to give me a positive root 2 over 4. Minus, now that's minus a root 2 times negative root 3, so minus a minus 6 gives me a plus 6 over 4, and I would write that all as one fraction, root 2 plus root 6 over 4. And then the tangent, well, we have the tangent of a sum, so the formula goes as follows. Tangent of u plus tangent of v over 1 minus tangent u times tangent v. Now this is a little trickier because, Ella, no, not that. Sorry, my dog is chewing something that she's not supposed to be. No, Ella, no. So this is a little bit trickier because now, you know, if you're thinking about the tangent, tangent of 135, well, the tangent is the sine divided by the cosine. Well, in this case, it's pretty easy. I know tangent's negative in this quadrant because I have a positive divided by a negative, and, you know, root 2 over 2 divided by root 2 over 2 is 1. So, anyway, I get a negative 1 for the tangent of 135. The tangent of 240, so coming down here, Okay, the tangent of 240 is negative root 3 over 2 divided by negative 1/2. So a negative divided by negative is going to give me a positive value. But what you're going to think about is, that's root 3 over 2 times 2 over 1. Just multiply this by the reciprocal of that. And the 2's cancel, so you get a positive root 3. Okay? And then, again, we found out that this is 1 minus, the tangent of 135 is negative 1, and the tangent of 240 is root 3. And so on top we have negative 1 plus root 3, and on the bottom we have 1 minus a minus 1, or 1 plus 1 times root 3 is 1 plus root 3. So getting that tangent, you got to practice that. It's just y over x. But you might have to do a little bit of arithmetic to simplify it. In 52, you're asked to rewrite. So in class, I believe we had one with the sine or the cosine. Now they're giving you the expanded form, so you're going to have to write it in a compact form. So what this means is, since I have a minus up here, this means it's the tangent of 68 minus 115. So I can rewrite this whole mess like so with my difference formula, and then I can just subtract 115 from 68 to give me the tangent of negative 47. That's all you have to do. A few more problems. Number 54. They're giving you that the tangent of angle U is 3/4 and that it's in quadrant 1, and they're telling you that the cosine of angle V is negative 4/5 and that it's in quadrant 3. So like I said in class, the first thing I want you to do is draw two right triangles, one with angle U and one with angle V. If the tangent is the side opposite over the adjacent, then I can fill in those two sides and use the Pythagorean theorem to find the third. Well, likewise with the triangle with angle V, the cosine is 4/5. Now remember, I can't have a negative side of a triangle. So this sign is indicative, or means, that since it's in quadrant 3, the cosine's negative. Okay, that's all that means. But anyway, it's the adjacent over the hypotenuse, so again, using Pythagorean theorem, I can find the missing side. Right? So 25 minus 16 is 9, and the square root of 9 gives me 3. So, if we want to find the tangent of u plus v, well, the formula is here, right? Now, the tangent of u is opposite over adjacent, so 3/4. It's in quadrant 1, so everything's positive in quadrant 1, plus the tangent of v. Now, this is quadrant 3, right? And in quadrant 3, the tangent's also positive because the sine and the cosine are both negative. So the tangent of angle V is the opposite over the adjacent, so 3/4 again. And then on the bottom it's just going to be 1 minus 3/4 times 3/4. Well, if I clean up the top, the denominators are the same, so I just need to add the numerators. So 3 and 3 gives me 6 over 4, divided by 1 minus 9 over 16. I reduce 6/4, right? I divided up and down by 2, so I got a 3/2 there because I want it as simple as possible when I clean it up. And over here now, I have to make this one fraction. So 16 times 1 is 16, minus 9 gives me a positive 7, back over the common denominator. Again, if you want to do this work on the side, I have to make, so this is 1 over 1 divided by 1, right? I need to make this look like, I need to make this denominator look like that denominator in order for me to add or subtract. So you can multiply up and down by an equivalent fraction, 16 over 16. And if I multiply straight across, I get 16 over 16 minus 9 over 16. And now my denominators are the same. And I can do 16 minus 9 on the top, which gives me a 7. Okay, so you can do it that way too, whatever you feel comfortable with. And now at this point, I really need to clean this up. So just remember, whatever's in the numerator, write it down, change division to multiplication, and flip the bottom. And what I see is that 2 goes into itself once, and it goes into 16 8 times, so I'm left with 3 times 8, which is 24, divided by 1 times 7, or 7. In number 55, so we're still using these same triangles and the same information for number 55, but now they want the cosine of u minus v. Well, the difference formula for the cosine is cosine u cosine v plus sine u sine v. So again, if I look up at my triangles, and I'm talking about the cosine of u, well, the cosine of u is 4/5. So I'm going to plug that in for the cosine of u. The cosine of v is 4/5, but it's negative because it's in quadrant 3. So down here I have 4/5 from 4/5 for angle u, which is quadrant 1 or positive, times 4/5 negative from quadrant 3, plus, now I have to do the sine of u times the sine of v. Well, again, if we look back up here, the sine of u is 3/5 and it's positive because it's quadrant 1. And it's also 3/5 for angle v, but it's negative because it's in quadrant 3. So it's this times the negative of that. If I multiply across, I get negative 16 over 25 plus negative 9 over 25. My denominators are the same, so that makes computation easy. A negative 16 plus a negative 9 is a negative 25, and a negative 25 divided by a positive 25 gives us a negative 1. Finally, I didn't get to finish number 63 in block 3. I think I finished it in block 1, but I don't think I finished it in block 3. So I wanted to do it over. You're asked to find the sine, cosine, and tangent of 2u, the double angle formulas. Again, you'll have a formula sheet for that. What they're telling you, the information that they're giving you, is that the sine of angle u is 4/5, and that angle has to be between 0 and pi over 2. That's quadrant 1 angle. That's good, because all of our sine, cosines, tangents, and their reciprocals are positive in that quadrant. So, I make a triangle with an angle u here, and I'm using the fact that the sine is the opposite over the hypotenuse, and Pythagorean theorem to find the missing side. Now that all my signs are put in, now that I know this is quadrant 1 and everything's positive, now I can use my formulas. The sine of 2u is equal to 2 times the sine of u times the cosine of u. So I'm just plugging in. It's 2 times the sine of u is 4 over 5. The cosine of u is 3 over 5. If I multiply, I have 12 times 2 is 24 over 25. Oops. I'm done. For the cosine of 2u, again, there's 3 formulas you can use, but if you are terrible at fractions, I really suggest that you use this formula here. Why? Because it's going to take anything that's negative and make it positive because you're squaring it, and also it's going to make your denominators the same, right? So it's going to make the arithmetic easier with the fractions. So if I square this, I get 9/25. If I square this, I get 16/25. 9 minus 16, the signs are different. We subtract and use the sign of the bigger number. 16 is bigger, so I get a negative 7 over 25. Finally, the tangent of 2u is a nice little formula. It's 2 times the tangent of u over 1 minus the tangent squared of u. Well, if I look back at my little triangle here, the tangent is the opposite over the adjacent. So it's 2 times 4/3 divided by 1 minus 4/3 squared. 2 times 4/3 is just 8/3, and I can't reduce that down, divided by 1 minus 16/9. Again, I'm going to do 9 minus 16 on the bottom here, so I've got 8/3 on the top. I'm going to do 9 minus 16 is a negative 7 back over the common denominator. And then to simplify this, I'm going to take the numerator and write it down, take division and change it to multiplication, and flip that bottom, that denominator, to negative 9/7. What I see is that 3 goes into itself once, and it goes into negative 9 3 times. So I have 8 times negative 3, which is negative 24. Oops, over 7. Okay, so I hope that helps. Don't forget, your test is Thursday. I did forget to give you guys the unit circle test again today, but maybe I'll incorporate that into Thursday's test and just give you 6 minutes to write it down, and then you can use it to help you solve the problems. All right, have a good night.